Welcome to Concept 4, Significant Figures. In physics, every measurement has a limit. When you measure a pendulum's period as 1.62 seconds, the 1 and the 6 are completely reliable. But that 2 at the end, that is an uncertain digit, limited by your stopwatch. Significant figures are simply all the reliable digits plus the first uncertain digit. The NTA loves testing the NCERT counting rules. Let's break them down. First, all non-zero digits are significant. That is easy. But what about the zeros? If a zero is trapped between two non-zero digits, it is always significant. 2.005 has 4 sig figs. The real trap is with trailing zeros. For a number greater than 1 with no decimal point, the trailing zeros are strictly not significant. 100 has only one significant figure. But the moment you add a decimal point, those trailing zeros become significant because they indicate the precision of the instrument. 100.0 has 4 sig figs. For numbers less than 1, zeros preceding the first non-zero digit are never significant. They just hold the decimal place. In 0.0023, those first 3 zeros are useless for counting. Now let's talk about math operations. Rule number 1. For multiplication and division, you count the total significant figures. The final answer cannot have more significant figures than the input with the least sig figs. If you divide a mass with 4 sig figs by a volume with 3 sig figs, your final density must be rounded to exactly 3 sig figs. Rule number 2. For addition and subtraction, forget about total sig figs. You only care about decimal places. The final answer must retain as many decimal places as the original number with the least decimal places. Finally, the 5 rules for rounding. If the digit to drop is greater than 5, raise the preceding digit by 1. If it is less than 5, leave the preceding digit alone. But what if the digit to drop is exactly 5? If the preceding digit is even, leave it unchanged. 6.25 becomes 6.2. If the preceding digit is odd, raise it by 1. 6.35 becomes 6.4. And remember, if you are multiplying by an exact count, like 2 balls or 6 faces of a cube, that exact number has infinite significant figures and does not limit your precision. Let's jump into question number 1, directly testing the NCERT zero counting rules. We need to find the number of significant figures in 3 different measurements. Let's look at measurement 1, 0.005020 grams. Because this number is less than 1, the leading zeros simply indicate the decimal position. They are strictly not significant. However, the trapped 0 and the trailing 0 at the end of the decimal are significant. This leaves us with 4 significant digits. Measurement 2 is 50,200 centimeters. This is a number greater than 1 with no decimal point. According to NCERT, terminal zeros in a number without a decimal point are strictly not significant. So we drop the 2 trailing zeros, leaving us with exactly 3 significant figures. Finally, measurement 3 is in scientific notation. NCERT states that the power of 10 is completely irrelevant to significant figures. We only look at the base number, 5.020. Since there is a decimal point, all 4 digits are significant. So our final sequence is 4, 3 and 4. Option 1 is the correct answer. Moving to question number 2. This is a classic NTA setup designed to test if you confuse the arithmetic rules. Taking into account the rules of significant figures, what is the calculated value of 9.99 meters minus 0.0099 meters? Step 1 is the raw math. When we subtract these two numbers on a calculator, we get 9.9801. Step 2 is applying the NCERT rule. Because this is subtraction, we do not care about the total significant figures. We only care about the decimal places. We must limit our answer to the input with the least decimal places. Look at 9.99. It has exactly 2 decimal places. 0.0099 has 4 decimal places. Therefore, our final answer must be strictly limited to 2 decimal places. We round 9.9801 to 9.98. The major trap here is option 4. If you rushed and used the multiplication rule, you would count the 2 total significant figures from the second number and round to 9.9. Don't fall for it. Option 3 is our correct answer. Let's look at question number 3.
Each side of a uniform metallic cube is measured to be 6.372 meters. We need to find the total surface area with appropriate significant figures. We know the formula for the total surface area of a cube is area equals 6 times side squared. Let's do a quick variable check. The measured side length 6.372 clearly has exactly 4 significant figures. But here is the ultimate NTA trap. What about the number 6 in the formula? If you count the 6 as having only one significant figure, you will round your final answer down to just one digit. That is completely wrong. The number 6 here is an exact geometric constant because a cube has exactly 6 faces. NCERT states that exact numbers possess an infinite number of significant figures. They never restrict the precision of your calculation. Therefore, our final answer must match the 4 significant figures from the measured side. The raw math gives us 243.614 and rounding that to exactly 4 significant digits gives us 243.6. We can safely cross out options 1, 3 and 4.
Question number 4 targets the unbiased exactly 5 rule. According to the strict rounding conventions detailed in NCERT, which of the following pairs of numbers will both round off to exactly 2.74? The NTA loves to trick you here by relying on what you learned in middle school. In standard math, a trailing 5 is always rounded up. But in scientific NCERT rules, we use the even-odd convention to prevent statistical upward bias. Let's check 2.735. We need to drop the 5. Look at the preceding digit 3. Because 3 is odd, the rule says we raise it by 1. It correctly rounds to 2.74. Now check 2.745. Again we are dropping a 5, but this time the preceding digit is 4. Because 4 is even, we leave it completely unchanged. The 5 just drops off, giving us 2.74. Therefore, both of these numbers round perfectly to 2.74. Option 1 is our correct answer.
We have reached question number 5. This is a classic mixed precision NTA trap from NEET 2026. We are given a metallic cube with a mass of 5.580 kilograms and a side of 9.0 centimeters. We need to find the density. Step 1. Check the input precision. The mass has 4 significant figures. The side length 9.0 has exactly 2 significant figures. Step 2. Let's do the raw math. First, we find the volume by cubing the side length in meters, giving us 7.29 times 10 to the power of 3. Then we divide mass by volume. The raw output is 7654.32 recurring. Step 3 is the trap. Students look at the intermediate volume 7.29, see 3 significant figures and assume the final answer must have 3. So they incorrectly choose option 2. Never do this. NCERT states you must trace precision back to the original measured inputs. No math operation can manufacture precision that your original measuring tape lacked. Our weakest link is the side length with just 2 significant figures. Therefore, our final density must be rounded to exactly 2 significant figures. We round 7654 to 7.7 times 10 to the power of 3. Option 3 is our correct answer.